Welcome to our lecture online. Here's our next example. Again, it can be quite challenging to see how to attack some of these problems. Here we're given an interesting figure, but we're indicated that these two lines are parallel to one another, and we're trying to find the value for x and y. Now, if you take a look at this line right here, the diagonal right here, and these two lines, then you realize that this here is a transversal to these two parallel lines. Then you can look at 4x and 52, and then you realize that those are alternate interior angles, and by the theorem of alternate interior angles, they must have the same measure. In other words, we can write that 4x degrees must equal 52 degrees. Divide both sides by 4, and we get x degrees is equal to 13 degrees. Now to find the value for y, here we see two parallel lines, and we're indicated that this angle here is 90 degrees, which means if this here is a transversal to these two parallel lines, and this angle is 90 degrees, then this angle must be 90 degrees as well. It turns out that the sum of 4x and 3y plus 2 together, that angle together, is equal in value to 90 degrees, because these would then be considered interior consecutive angles. And interior consecutive angles add up to 180 degrees, but if one of them is 90 degrees, that means the other one must be 90 degrees as well. We can then write that 3y plus 2 degrees plus 4x degrees is equal to 90 degrees, because these two angles together plus this angle must add up to 180. If this is 90, then the sum of these two must be 90 as well. And now we can solve for y, since we already know what x is equal to. 4x degrees is equal to 52 degrees, so we can write that 3y plus 2 degrees plus 52 degrees is equal to 90 degrees. Subtract 52 from both sides. 3y plus 2 degrees is equal to 90 degrees minus 52 degrees. And let's see here, add 38 to this gives us 90, so we can write that 3y plus 2 degrees is equal to 90 minus 52, that would be 38 degrees. Notice we can now move the 2 degrees to the other side, so we have 3y degrees is equal to 38 degrees minus 2 degrees. Whoop, that one is a little bit too big. Let me get rid of that. There we go. Minus 2 degrees, which means that 3y degrees is equal to 36 degrees. And then if we divide both sides by 3, we could then say that 3y degrees equals 36 degrees. Divide both sides by 3 degrees. And we can see that y degrees is equal to 12 degrees. So now we have a value for x, and we have a value for y. Again, using the same theories and postulates that we did before for parallel lines and transversals. And that is how it's done.